Okay, so activity 5.4, making sense of the discriminant. A quadratic function can have one unique real zero, two real zeros, or at times no real zeros. So this relates to the lesson yesterday. So there's three choices: one unique real zero, two real zeros, or no real zeros. So there are always two zeros in any function, but they might repeat, in which we'd only see one different or unique zero. There might not be all real. So we could have no real zeros because they're complex. So let's investigate how the quadratic formula can inform you about the different types of zeros. So we have three quadratic equations. The first one, y equals x squared. And if we look at the graph, we can see this has one repeated real zero. So one repeated real zero. And if we look at this one, it crosses at two places, so it has two real zeros. And this one does not cross the x-axis anywhere, so it has zero real zeros. And that means it would have complex zeros, which you'll learn about in Algebra 2. And you might hear them as imaginaries, which we haven't learned about. Like I said, you will in Algebra 2. So it says use a quadratic formula to solve each quadratic equation and show your work. So let's look at the first one. We have y equals x squared plus 0x plus 0. We're going to put in our zeros. So a is 1, b is 0, c is 0. So we have negative 0 plus or minus the square root of 0 squared minus 4 times 1 times 0 all over 2 times 1. If we simplify that, we have negative 0 plus or minus 0 minus 0 over 2. Negative 0 plus or minus 0 over 2. So if we take negative 0 and add 0 and divide by 2, we get 0. And 0 minus 0 divided by 2 is also 0. So you see how we get one repeated real zero. So that's why on our graph, we see the only answer is 0, and it bounces or turns and turns back there because it repeats. So that's the first one. The second one, y equals x squared plus 0x minus 1. Okay, so we plug in the second equation. A is 1, b is 0, c is negative 1. So we have negative 0 plus or minus the square root of 0 squared minus 4 times 1 times negative 1, all divided by 2 times 1. Negative 0 is negative 0 plus or minus the square root of 0 plus 4 over 2. Negative 0 plus or minus the square root of 4 over 2. So then we have negative 0 plus or minus 2 over 2. If we split that apart, negative 0 plus 2 over 2 and negative 0 minus 2 over 2. We get 2 over 2 is 1, negative 2 over 2 is negative 1. And again, that gives us two real zeros, one at 1 and one at negative 1, as you can see in the graph. And then the last one, we're going to have y equals x squared plus 0x plus 1. And therefore, a is 1, b is 0, and c is 1. So we have negative 0 plus or minus the square root of 0 squared minus 4 times 1 times 1, all over 2 times 1. Negative 0 plus or minus 0 minus 4 over 2. Negative 0 plus or minus the square root of negative 4 over 2. And right here, we can see that this is not going to be real. Because we have a plus minus, there's 2 not real. Okay, so again, we have no real zeros in this case, which is why it doesn't cross the x-intercept. So then the question asks, what do you notice about the relationship between the number of real roots, the graph, and the result of the substituting the values in? So let's start. If we have one repeated zero, it only has one x-intercept. And if we look at it, it has one solution. So one real root has one x-intercept, and it bounces there, and it has one solution. if we have two real roots, it has two x-intercepts on the graph, and it has two solutions. And if we have zero real roots, we have zero x-intercepts, and we have zero real solutions. And if we go back and focus on what part of the equation makes this happen, and I'm going to get my highlighter so we can see this better. If you notice on every equation, this part is the same in all three equations. That part is exactly the same, right? So what is causing these different results? The part that's causing these different results is the part here, right? The part under the radical, or the radical part. So the part under the radical, because in this case, under the radical gave me 0. When we take the square root of 0, we get 0. This part gave me a 4, and then we got the 4 here, which brought us down to the 2. And then this one gave me a -4, right? And if we think about what that means, when you get 0, when you add or subtract 0 from a number, you get the same result whether you add or subtract 0, which is why you only get one answer. If you add or subtract a number other than 0, you're going to get two answers, one when you add and a different one when you subtract. And then over here, if you end up with a non-real number, because you end up with a negative when you do this, then you end up obviously getting not real solutions. So the part under the radical sign, that part under the radical sign determines what is going to be the outcome. Are we going to have a bounce? Or are we going to have two x-intercepts? Or are we going to have no x-intercepts? So that particular part of the equation, which is the b squared minus 4ac portion, of the quadratic formula, is called the discriminant. And the reason why is because it discriminates the number of zeros or roots. So that part of the equation will let us determine how many real zeros or roots there are. So you don't have to do the whole problem out to figure this out. So using the discriminant, write an inequality to describe when a quadratic function has each solution. So if there's no real roots or zeros, the discriminant b squared minus 4ac has to be less than 0. In other words, a negative number. If you take the square root of a negative, you're going to get no real. Okay? And one real solution means the b squared minus 4ac must equal to 0. Because again, when we add or subtract 0, it gives you the same value. And then two solutions is anytime b squared minus 4ac is greater than 0. So any real number, when you add and subtract it, will give you different results. So it says, how can you tell how many zeros a function will have before using the quadratic formula? You're going to plug in just the discriminant part, and that will tell you. So every quadratic equation with a real coefficient has either two real roots or 0 real roots. However, if a graph of quadratic equation has one x-intercept, the equation will still have two real roots. This two real roots are considered a double root. So now the directions here say to use a discriminant to determine the number of real zeros for each equation. So we're going to look at the first one together, and then you'll try the rest on your own. If they have a y equals, replace it with a 0. So we're going to identify A, B, and C. Sorry, I put an extra equal sign in there. A is 2, B is 12, C is -2. And the first thing we're going to do is our discriminant. So the discriminant is just the b squared. So b squared minus 4 times A times C. And 12 squared is 144. -4 times 2 is -8. -8 times 2 is +16. So when we add those together, we get 160. So that is the value of the discriminant, and it says determine the number of real roots. So now we go up and we say, is 160 less than 0, equal to 0, or greater than 0? Well, it's greater than 0, which means it's going to have two real roots. So that's the second part of the question. So the first part says use a discriminant to determine the number of real roots, and then the second part says solve. So to finish solving this, now we need to go and do the rest of the quadratic formula. So the quadratic formula is negative b, so negative 12, plus or minus the square root of the discriminant. So we can put the 160 right into there, divide by 2 times 2. And if I simplify this discriminant, the square root of 160 is 16 times 10. The square root of 16 is 4. So we have negative 12 plus or minus 4 root 10 over 4, which can reduce, everything's divisible by 4. So 12 divided by 4 is 3. And then 4 divided by 4 is 1 root 10. And so then this is the answer, or the two answers. X is negative 3 plus root 10 and negative 3 minus root 10. So if you want to write that out, so you have exact answers, negative 3 plus root 10, and then x equals negative 3 minus root 10. And those are your two real roots, and they are irrational. All right? So when you're thinking about discriminant, you're doing the part under the radical first, and then you can just plug that back in. You don't have to resubstitute it all in. You can just plug that number in here. Right? So actually, let's look at the second one together, and then you can try the rest. So A is 2, B is 12, and C is 20. So we start with B squared, so 12 squared minus 4 times A times C. 144, and then negative 4 times 2 is negative 8 times 20 is negative 160. And if I subtract, I get negative 16. And negative is less than 0, so no real roots. So we're going to write no real roots. So this is our first part of the problem. Find the discriminant, say what the roots are, and then to write what the final answers would be. If there's no real roots, we know that the final answers are going to be no real roots. So you really don't have to solve this, but if you were to plug this in, negative 12 plus or minus the square root of negative 16 over 2 times A is 2. So we have negative 12 plus minus the square root of negative 16 over 4. And because this is not real, you would say not real. And you wouldn't be able to go any further until you get to more advanced math classes. So you're going to do C, D, E, and F. Make sure on E you put your placeholder in and put the 0x there. And then find the discriminant, state how many roots there are based on the values above, and then solve by plugging that value in. Again, your discriminant plugs in right inside the radical, and then simplify.